let's start putting those moment arm ideas into actual exercises rather than slightly random drawings on Canva of things, right? So because that's where we're going to need these guys, in the actual gym. So we're going to try and provide you with a 3-step walkthrough to help you identify these things when you take your own pictures or videos, or when you're looking at clients or whatever, and you're trying to see what's going on. This is what we want you to do. And by the way, please, please, please do this. The way this shit will consolidate in your mind is by you actively drawing and doing. It's not enough just to passively hear me say this stuff. It won't stick for you in any meaningful way when it matters, which is at the gym, right? We're practical creatures. We're not theoretical creatures as trainers. Okay, you have to do, okay? So these are the 3 things I want you to do. 1, identify the point of rotation. Identify the axis. Now, an axis you could think of as just a point that other shit is spinning around, like the sun in the solar system, the moon around the earth, okay? My elbow joint, my shoulder, something in a machine, whatever, right? Identify an axis, and there can be more than one axis to look at within stuff. Then identify the line of force, what forces are at play here, because there could be more than one, right? There can be multiple forces acting around any given axis. Where's it going? Where's the directional bit? If you really wanted to, identify the whole 3 things about the force. There's its direction. Do I know its magnitude? You won't always know its magnitude, but do I know it? I know it. And where's it interacting with the thing, the person, the machine, etc. Point of application. And then finally, once we've got the line of force and an axis, we go, okay, how do I find what was the definition of a moment arm? Ah, crap, it was the perpendicular distance between something and something. God, what was it? Perpendicular distance between the axis and the line of force, right? Okay, cool. Well, we've got those. Point of rotation, the line of force. So I need the perpendicular distance between the axis and the line of force. Find the fucking T-shape, okay? So let's put this into some exercises. So we're back here. We've got that chest press that we've looked at before. We did the 3 parts of a force on this. We had point of application was the hand, magnitude was 25 kilos, direction was straight fucking down. So let's find the torque that this thing is generating over the joints in question. Okay, so we've got the line of force, that's already put in there. Axes. What axes are these primarily interacting with, having an effect on? What do we think it trains? Shoulder, elbow. Let's go that. Right? If you did it one arm, there's all the spinal stuff because it'll pull you over to the side, but that's being balanced out by the other guy, so don't worry about it for now. Right? We're just thinking shoulder and elbow. They're going to be our primary ones. So let's put them in. Boom, shoulder and elbow. And now we're trying to find the perpendicular distance, the T shape, between this line of force and that guy over there and that guy there. So T shape. Well, if I went straight from the axis across, boom, hopefully you can see that little gap there. That's going to be the moment arm to the elbow from this exercise. And how about this guy? Well, if I start at the axis and I come straight across, and that kind of makes the T shape there. Let's assume I can do it really, really straight, which obviously I can't because I'm using a mouse, right? But it's going to be this line along here. So we put those in, and there are our moment arms to that line of force for those guys. What does that mean? Well, I've got a bigger one to the shoulder than the elbow. So 25 kilos times, what do we reckon the difference is between that? 3 times it? Maybe 4? Let's go 3 for the hell of it. Actually, no, let's go 4 because it's easier with 25. Right? So if we had 25 and that was 4, that would be 100 units of torque that the shoulder is being asked to deal with. And let's say that was 1, then that's 25 units of torque the elbow is being asked to deal with. You can then think, well, which way is it trying to drive those guys? Well, that line of force sitting this side of the elbow is trying to bend his elbow back towards him. It's pushing him into elbow flexion, which means his elbow extensors, which we're going to call your triceps, have to fire to actually stop that arm falling in. Cool. How about what's it trying to do to the humerus? It's trying to drive it back this way into like extension. So the guys at the front that pull it forwards need to fight. So pec, anterior delt, those guys are going to have to do some work around here as well. Okay, so that's what that means. It means we've got a bigger challenge to the shoulder stuff than the elbow stuff, and it means it's challenging the front of these guys and the triceps on this side because of where it sits in the axis as he goes through. Okay, let's move into this one. We did the cable lat raise before as well, 3-step walkthrough. Where's the line of force? It's along the cable, because we've said that's what cables do. Okay, what about, so in the hand, there's our point of application for the force. The direction of the force, the line of force is along there. The magnitude is whatever we've got after the cable stack and the pulley. What axis are we interested in here? Well, that's a lat raise, so hopefully you guys went shoulder, Paul. It's the shoulder. Cool, so let me stick the shoulder in there. Okay, and apparently I did this one a little poorly because that went straight in. Okay, so there's our shoulder axis, and that guy is now the moment arm to this, right? And you kind of notice that this line of force runs all the way along the cable. So we've sort of extended it, and we're going to talk in one of the future videos of forces about extending a line of force. But what we've got here is, there's a T-shape, there's 90 degrees between each of those things there, okay? So, cool, we've got a challenge in this position that is whatever this load is times that distance. That is the torque that his delts are responding to. The bigger that torque, the harder it is for his delt in that position. The smaller that torque, the easier it is for his delt in that position, okay? We go back to here, we're on a squat again now. So we've got the line of forces coming up. There's an arrow pointing up here, but you can't see me because I'm kind of in the way, right? We've not taken it from the dowel rod or the barbell. It's up from the midfoot. Okay, so that's our line of force. Can't squat on water and all that shit. Then we've got our axes, knee and hip. Obviously, there's ankle and there's all the spinal stuff. Of course, there's other things to consider. But for now, this is what we're thinking of. Okay, and can you start to see where that distance would be? This perpendicular distance, that T shape that's going to be in there. And then a T shape that's going to be in there. So if we click on it, there's the T to the hip, there's the T to the knee. What do we notice? Slightly bigger to the hip than it is to the knee. So from an external torque, again, let's say this was 100 kilos shoving up, and let's say that that's 3 and that's 2, because, you know, they look similar length, so maybe that's 2/3 of that length. Well, 100 times 2 means we've given the knee 200 units of torque, and I've given the hip 300 units of torque. I don't know what that means for him in terms of how he experiences it yet, because maybe his hip is stronger than his knee and some other stuff that we'll talk about within there as well. So just because there's a bigger external torque being given to a joint doesn't mean I know that it's harder for that joint. There's other things to consider, but that's going to be one of the big ones, right? Like if something is bigger to the knee or bigger to the hip, well, okay, I'm going to be wanting to consider that. You might find for some people that when they squat, there's almost piss all moment to their knee. In which case, the idea, like let's say that line of force sat kind of here. So the moment was like really small. It was like this. And that means that the moment to the hip is going to now go from here all the way across there. But the squat grows the quads, right? Not for that person. They've got a tiny moment to their quad, right? That's trying to flex their knee. Because if you look at what does that line of force want to do to the tibia and the foot, it's trying to bend it backwards. It's trying to drive knee flexion, which means the knee extensors have to fight it. What's it trying to do to the hip? It's trying to drive the hip up into your chest, hip flexion, which means the hip extensors have to fight it. And if there's a massive moment to the hip and a really small moment to the knee, then for that person in that position, that's not really a quad challenge. And some people find that. Like I was one of these people. I'd do loads and loads of squats and my arse would grow. My adductors would grow. My low back would hurt. And my quads didn't seem like they were growing that much. And yet other people, and again, we'll talk more specifically about this, do a squat, their quads blow up. A lot of the reason for that is just found in these proportions and what moments it gives to the relevant hip and knee as you go through. So please go and practice drawing on pictures and going, right, take a shot from the side of the squat. If I draw that guy up, there's my axis, there's my axis. Okay, that's my line of force, is it? Where's my perpendicular distance between the axis and the line of force? Okay, that T-shape, that's what perpendicular means because Paul keeps fucking saying it, right? I'm going, okay, can I start to see what these things are? Can you start to see these when you're watching clients do stuff or just watch other people in the gym and you go, oh yeah, they've got a bigger moment to the hip. They've got a slightly bigger one to the knee. Theirs are pretty even. Like, start looking around. This shit allows you to see inside the matrix and see stuff that's always there at play, but we just don't learn about. And we have to learn about it because these are the things that really make up exercises.